Hi everybody, this is page 6 in your study guide for chapter 6. You should have done pages 2 through 5 notes on your own. Page 6 we'll do together, page 7 notes on your own, and then page 8 you'll finish with a video. There are hopefully going to be a couple of videos on this topic for you because there are a few different ways to graph radical functions. I'm going to show you the way that I prefer, but there also will be another video I'll have you watch at some point as well. So starting on page 6, I'm going to show you how to graph y is equal to 3 times the square root of x minus 1 plus 2. So this sheet here is kind of designed for you to use a different method. I'm going to show you where we're plotting points, so let's rewrite this really quick. So what you started looking at in the pages prior to this are different pieces of square root functions, and a piece that we want to start looking at when we're doing this is what we call the endpoint. So it's like our h and k when we think back to absolute value functions, except this time we're calling it an endpoint versus a vertex. And remember, we are flipping h. So because this is our endpoint and kind of a vertex here from what we remember, I'm going to start with putting 1, 2 in my table. Then I'm going to go to my y equals on my calculator, and I'm going to type in 3 times the square root of x minus 1, and you want to be careful with your parentheses here because you want to make sure you're telling the calculator what is exactly under the square root and what's not. So you can use your arrow and parentheses to make sure that the plus 2 is not underneath. Then we like to go ahead and take a look at the graph. Okay, we see what it's going to look like. I'm going to close that. And let's go ahead and look at the table. So we know that we're starting with 1, 2, and I can see it there. Anything below it isn't working, and we'll talk about that in a minute. So I'm going to write down 2, 5. 5, 8. And you could use other points as well, but it's nice to find a few points you can plot that just aren't decimals. Okay, so let's go ahead and get some of these points plotted. So we've got 1, 2, 2, 5. And feel free to pause the video or rewind it, listen to something again. And now from here, I'm going to go ahead and draw my line. All right, and now we're done. Your homework will ask you a little bit about domain and range, but I'll make sure to talk with you about that in class. All right, so it says down here, why does the graph have an endpoint and what is so special about it? So let's go back to looking at our table here. So we said everything below 1, 2 is NA, and on your calculator you might see error. And what that means, think about when we talk about, can we take the square root of a negative number? And no, we can't. So if I were to plug in anything below a 1 into x, it would end up being a negative number, so it doesn't work. So we can write here 1, 2, it's an endpoint like a vertex, and points below one, 2 are an error because you can't take the square root of a negative number. Let's take a look at this next one together. So I'm going to go ahead and clear out my calculator and retype it in. I'm going to rewrite this to be the one that's above. So I'm going to write 2 times the square root, and in parentheses, x plus 3, arrow, then minus 1. Let's take a look at the graph. Just make sure I can see it. Okay. Close. I'm going to go back to my table, and I can see right away that I'm going to have my endpoint at -3, -1. So that is where we can start. So let's take a look there. All right, so I see -3, -1, everything below it, NA or error. So let's find a few points that I can plot. So how about -2 and 1, 1 and 3, 6 and 5, and 13 and 7. So let's go ahead and get those points plotted. And if it does help you, go ahead and look back at your calculator in your graph. What does that look like? Which way is it going? Try to do your best when you're making the sketch now that you've got points. And, well, I could try to get 13 and 7. That's like right over here-ish. And then go ahead and we'll make our curve. And there we go. We're done. All right. So if you have not completed page 7 yet, go ahead and pause the video and complete page 7. Then we can go ahead and go on to page 8. All right. So now this time we're talking about a cube root function. And if you're not quite sure what a cube root function is, remember the square root of 16 is equal to 4. And that's because 4 times itself is 16. When we think about a cube root, that's trying to say, okay, well, what times what times what gives me 27. So an easy way to do this is you can check in your calculator. You can go to your calculator and hit the math button in the far left side below the alpha. And if you look, you can see it's the fourth one down. So I'm going to go ahead and click it and type, oops, not 5. I want to type 27. 3. So what that means is 3 times 3 gives me 27. All right. So because it's a cube root, we can take the cube root of a negative number. Think about the cube root of negative 27. Well, negative 3 times negative 3 times negative 3 is negative 27. So you can take the cube root of a negative number. So from looking here, I know that I'm going to have a point, negative 3, negative 1, but that doesn't necessarily mean it's the end point. So let's go ahead and type this into our table. So I'm going to type in negative 2 to the cube root, negative 2 times cube root x plus 3 minus 1. So I'm going to go ahead and type that in, negative 2, hit math, cube root is the fourth one down, parentheses, x plus 3 minus 1. So once you have that typed in, we can take a look at the graph. Notice from what you learned on page 7 how it looks different. It doesn't have that endpoint. So let's go ahead and look for some points to plot. I know I'm going to have negative 3, negative 1. But if you look, I can see we also have negative 4, 1. So why don't we get that one written down as well? I also see negative 2, negative 3. See if we can find any more. I see 5, negative 5. All right, that's pretty good. So I'm going to go ahead and plot these points. Oops, wrong one. So negative 4, 1 is here, then negative 3, negative 1, then negative 2, negative 3, and 5, negative 5. So if you're having a hard time like picturing this and saying, well, I don't know how to make this into a graph, what I'll have you do is go ahead and hit graph and just look at it. I need to zoom in a little bit. Okay, so I see that I'm just going to do my best to sketch through it. So I can see it kind of looks like something kind of like that. It looks a lot better in the calculator, but we try. So it says here, this graph goes forever in both directions. Compare this to the square root function, and why doesn't this graph have an endpoint? So we talked about that a little bit because we can take the square root of a negative number. So therefore, our graph doesn't have an endpoint or a place where we can't keep going. So we can write that in a formal way by saying there are no domain constraints with a cube root. Because you can graph a cube root of a negative number. Okay, the next one is a U-try, so you can go ahead and do that one if you would like to. Otherwise, go ahead and you may move on to the next task that you have been assigned for today. Thanks, talk to you soon.